All right, everyone, the end of Chapter 8 is here. This is Lesson 8.10. It's actually an extension lesson. It's really a wrap-up of the three major types of functions that we've learned this entire year. So we stick it at the end of Chapter 8, but it's really it's really its own chapter in itself. Can you name all three of the major function families we've learned this year? You should be able to. But if you can't, they are, from the very beginning of the year, we started with linear functions. That's y equals mx plus b, right? Then we actually went to, next we did what are called exponentials, but I'm going to list it as third. We did exponential functions. And if you remember that format, it's y equals a times x to the b power. Okay, that's when the x has, I'm sorry, I wrote that wrong. It's a times b to the x power. It's when the x variable is in the exponent. Hence the name exponential, because the exponent is a variable. And then what we just finished up, chapter 8, were quadratics. That's y equals ax squared plus bx plus c. Right? Those are the three generalized formats of the three major function families that you learn in Algebra 1. So we basically just gave the standard formats of each. Y equals mx plus b, so an example of that would be like y equals 2x minus 3. That's linear. Right? A quadratic would be, you just plug in values for your a, b, and your c. So y equals 2x squared plus 5x minus 1. That's a quadratic example. And then an exponential, a times b to the x power. So maybe y equals 2 times 3 to the x. That's exponential. What characteristic of the equation makes it fit into the function's family? So basically, what's happening with the x variable? So in linear functions, the x is being raised to the first power, right? In quadratics, the x is being raised to the second power. And in exponentials, the x is the exponent itself. That's how you tell, okay? Sketch a graph of each function, so we should know that linear is just a line. That's a quick sketch of a linear. A quadratic, which we just got done studying, looks like a U-shaped parabola. And an exponential, if you remember, looks like it kind of starts like a quadratic, but it curves upward like that in one direction. And then it tails off to the other side. It rises real rapidly. Okay? Now, the key to the whole lesson. How do you tell from a table of values which is linear, which is quadratic, and which is exponential? Okay? So you should remember how to do this. Linear is probably your easiest one. Everyone should know how to figure out which one's linear, right? You look at the y values. See here, the y values are all going up by the same amount. In this one, they're all going up by 3, right? That makes it linear. There is a constant difference in the y values. Okay? Now, which we just studied, the quadratics, which would be this one down here. If you recall, you have to find the differences. So this one is a difference of negative 7.5. Then it's a difference of negative 4.5. Then it's a difference of negative 1.5. Then it's a difference of positive 1.5, right? But then with quadratics, you have to look at the second differences. You have to do the differences of those differences. So to go from negative 7.5 to negative 4.5, you're actually adding 3. To go from negative 4.5 to negative 1.5, you're adding 3. And then to go from negative 1.5 to positive 1.5, you're adding 3 again. So this, what are called the second differences. Second differences are constant. That makes this quadratic if the second differences are constant. Okay? So in linear, the first differences are constant. In quadratics, the second differences are constant. And then in exponentials, there are no differences. There is a common ratio. So to go from 16 to 4, you're dividing by 4, right? And then to go from 4 to 1, you're dividing by 4 again. And then 1. So if you're dividing by the same number, as opposed to linear or quadratic where you're adding or subtracting the same number, exponentials multiply or divide the same number. It's actually, you're always supposed to express it in terms of multiplication. So you're actually multiplying by 1/4. You're multiplying by 1/4. Actually, let's write it like with a little dot. You're multiplying by 1/4. You're multiplying by 1/4. You're multiplying by 1/4, and you're multiplying by 1/4. There is a constant factor. That's the word. It's no longer a constant difference. It's a constant factor among y values. All right, and that's the whole lesson. That's all you have to do. You just basically have to determine which one's linear, which one's quadratic, which one's exponential by looking at a table. All right?